Good day everyone, I am Alvin Bohol and today I am going to discuss to you one of the topics in computer programming and that is problem solving through flowchart tool. Now at the end of this lesson, we are expected to generalize word problems into technical work items necessary to write workable solutions. And number two, convert work items into workable solutions and interpret solutions by steps. And number three, write flowcharts and pseudocode equivalent of the solutions and explain the design flow. And number four, argue whether a provided flowchart and or pseudocode is appropriate for the given problems and their underlying solutions. Okay, so understanding the logic applied to flowchart is easy. However, creating a flowchart that complies all the set standards to make the design efficient and well organized is not easy. So that is why in designing flowcharts, we need to consider all possible inputs based on the scope of the given problem just to ensure that the design we are creating is well organized, efficient, and solve the problem accurately. So throughout this lesson, we will learn the things need to consider to have an efficient flowchart design. Okay, so let's start. So the first thing we need to do is to understand the problem. Okay, so like any other problem solving, understanding the problem is the first step to make if we want an efficient, organized, and working flowchart. So to better understand the given problem in computer programming, we need to identify these keywords and categorize them into steps as technical work items. So technical work items are short, keyword-driven phrases which summarizes all the essential parts of the problem. Then these technical work items are guided using the following characteristics. So now we will discuss the characteristics of the technical work items. The first is a concise. So this means a concise means shortly written work items. So having a shortly written work item will help us identify exactly what needs to be accomplished. So this means that the written work item is brief, clear, and to the point. In other words, the written work is short but effective. Okay. Next is we have unambiguous. So unambiguous means simplicity of how work item was written. So this means that the written work item is clear, definite, and free from any doubt or confusion. Next is we have classifiable. Okay, so technical work items should be classifiable in one of the three. So namely input, process, and the output. So when we say input work items are those that require user information, user intervention, and ask for some actions from the user. So in input, we are asking from users to input data or to enter data or something. Then the process work items are those that the computer itself will do, like perform some series of computation. And lastly, the output. Output work items are those that require the user to recognize a result coming from our program. Okay. Next is we have a specific. So each work item should be point to only one thing that needs to be accomplished, may it be to ask the user for his first name or last name, but not both. Now let us try this problem to better understand those characteristics. Okay, so our first example is write a program that displays hello world. So this problem is simply asking us to display a series of specified text to the user. Okay? It does not include any request for the user to enter values to our program. So the solution to this problem lies on inputting the text hello world to the user. Then our program ends. Okay. So understanding the problem, it is just simply asking us to display a series of specified text hello world to the user. Okay. So now that we understand the problem, okay, we know the problem already, let us try to work our technical work items. Okay, so this is our technical work items. So since we are only asking to display a series of specified text, our technical work item is this one. So this is to display hello world. Simple. Okay. And since we have done interpreting or understanding the problem and have already our technical work items, it's time to create or write our flowchart, okay, based on the problem. So and here is the example of our flowchart based on this problem. Okay. So here is our flowchart. So as you can see, we start with a terminal symbol and ends with a terminal symbol. Okay, so and inside of these terminal symbols, we have the process. So we can enter here a decision and on page or off page. But here in our program, we just use this data symbol, which will display the hello world. Okay, so this is our flowchart based on our problem. Now for our pseudo now for our pseudocode, here is our pseudocode based on our problem. Okay, so since flowchart one, this one is devised to display the string hello world, so we will only use the output keyword of our pseudocode convention. Okay, so remember in our last topic about the keywords, so we have this input, we have the output and input keywords. But now we are going to use an output keyword because we are asking to this our program to display a hello world or to have an output of a hello world. So this is our pseudocode with this problem. Output hello world. Now let us try with another example. Okay, so our problem is write a program that adds two numbers from the user. Okay, what is the first thing we need to do? Okay, we need to understand the problem. Now here in our second problem, this problem is not, is more, I mean, is this problem is more complicated compared to our first problem. Okay, because, and to solve this problem, we need first to understand what is the problem all about. So as you can see, there are three phrases. We have the adds, this one, then the two numbers, and from the users. Okay, so the phrase adds means that we are asking the computer to perform a calculation. So mainly, since this is add, we are going to use an addition operation. Okay. And next phrase, we have two numbers. So two numbers suggest that the calculation should be performed or should be made only onto a specific numbers. However, as you can see, this phrase is not clear as to what kind of number we are going to use. For example, if these two numbers are referring to only integers or a floating points. And since this problem is vague, we should conclude or interpret that the problem is accepting, or these two numbers is accepting all kinds of numerical inputs such as the integers and the floating points. Now for the last phrase, we have the from the user. Okay, so this suggests that the numerical input will be coming from the user. So this phrase means that the numerical input, again, so is coming from the user. So they are the one who will enter the first and the second number. Okay. Now, so since we already understand the problem, let us discuss or let us know what is our technical work items based on this problem. Okay. So here is our technical work items. So since we are asking from the user, okay, we have this term. So we ask user to enter a number as the first number. So here is our technical term to ask user for the first number. Then we need to ask user for the second number, and then to display the sum of the two numbers. Okay, so this is our technical work items. Now for our pseudocode and flowchart, here is our flow chart and pseudocode based on the problem. Okay, so here here we start with this one, the symbol, terminator, and another terminal symbol. Okay, the start and the end symbol. Okay, these are terminator symbol, the start and the end. After that, we ask a user to enter the first number. Okay, and then that entered number by the user is restored as num1. Remember that when we ask a user for an input, we immediately store that input to a temporary container which we call variable. Okay, so after asking user to input a number one, a number for the first number, then we ask again the user to enter a second number for our num2 variable. Okay, then as you can see, we use a separate variable. Okay, so we use separate variable just to avoid overwriting our previously created variable num1. So and lastly, we have displayed symbol which contains the sum of the num1 variable and the num2 variable. So notice here that we did not create a third variable. Why? Because we do not need the sum anymore after displaying its value. Okay, so this means that we only use variables if we intend to keep them for future use. So, however, in this problem, we do not need the variable num3. Okay, so because we terminate the program after displaying the sum of the num1 and the num2. So we terminate the program through our end terminator of flowchart. Okay, so now for our pseudocode, here is our pseudocode based on our flowchart or on our problem. So since this flowchart is devised to display the sum of two numbers from the users, so for this we will use an additional keyword input. Okay, so instead of declaring only an output, so since we are asking a two number from our user, so here we put this input. So this is our pseudocode for our problem number 2. Okay. Next problem is, let's try this more complicated. Okay. Write a program that reverses a string input from the user. Okay. So this problem is not much complicated in functional sense. However, it became complicated because the computer's perspective, this requires a lot of work. Okay. So this is because of how the computer processes strings. So in computer, for example, computer do not read strings like how we read them. So computers see them as a series of precise characters and nothing more. So that is why we need to reverse a string. Okay, or to reverse a string, the computer needs to read each character of the string starting from the last character until the first character and storing them to display to the user. Okay, so we need to reverse the string because the computer is not like read, because the computer read backward, not like humans that we read this program as forward. Okay, so that is why we need to use a reverse string. So now back to the problem. Okay, we need to understand the problem. So to solve this, so here is our problem. Okay, first is our main objective is to reverse a given. Okay, is to reverse a given string as suggested by the phrase this one, reverse a string. And as discussed previously, reversing a string means we read each character from the end to the beginning of the string. Okay, so and as suggested by the phrase string input, okay, string input from the user, this means that the string will be coming from the user. Okay, and lastly, for our output, we have the reverse string. Okay, so this is the result of the program. So, and now that we have learned or understand the problem, let us know what are the technical work items we used here. Okay, so our technical work items is here. So we ask user for a string to determine the length of the string as x. Okay, so to check if x is greater than 0. If 0, to end processing. If work item 3 is a no, then we need to display the x character. So to subtract 1 from x, then to return to work 3, this one, to continue and processing the rest of the character. Now to fully understand how these technical work items work in a flowchart, let us create our flowchart. Okay, so this is our flowchart based on our problem. So here we started with a terminal symbol start flow. Okay, we start on our flowchart and ended with this one. Okay, terminal symbol start and terminal symbol end. So here we started with accepting this one, accepting from the users. Again, we store the string input to a variable named str. Okay, str1. So we restore the input value that the user entered. After which we determine the length of the str1. Okay, and store it to another variable named x. Okay, so by this time we have two different variables. So we have a string variable, the str1, and a numerical variable, the x. And for the fourth symbol, the conditional, or this is a decision symbol, so it is used to test our variable x of its value. Okay, so since we will retrieve only the existing characters of the string, we will proceed to end terminator if the length of the x is 0. Okay? So while it is yet to be 0, we will retrieve the x character of the string 1, and once we get or we retrieve the character we display it to the user, then we proceed to our next operation, which is a symbol process. No? This is a process symbol. We use this process because we are only to perform mathematical computation against x variable. And that is why we use this variable. So we subtract 1. Okay, so we subtract 1 from the value of the x to get the next character. Okay, after this, we return this one, we return to the fourth symbol. This one is our fourth symbol, and repeat the entire iteration again. So if x is equals to 0, then terminate the program because it meets the condition. If not, then we will go here to retrieve the x character of this one, then continue the process and go back here again until the value of the x is equals to 0. And now for our pseudocode. So based on flowchart 3 is device to reverse the given string and display it back to the user. Flowchart 3 would have an equivalent pseudocode as follow. So this one. So this is our pseudocode based on the problem. So we have to declare the variable string 1, the variable x. We input the string 1. We use the do set to while do output, this one keyword, and here is our pseudocode based on our problem. Okay, so and here ends our discussion. So now let us summarize what we have learned from our discussion. Okay, so from the lesson, we are able to understand the things that we need to consider to solve the problem, such as first is understanding the problem. Okay, then writing the general word problems into technical work items, and we have converted the technical work items into workable solutions and interpret solutions by steps. Then we wrote the flowcharts and pseudocodes based on the given problem, and we are able to explain the design flow. And lastly, after applying all the necessary things and solving a problem, it enabled us to argue whether our flowcharts and or pseudocodes are appropriate for the given problem and their underlying solutions. So here ends our discussions, and I hope you have learned something. Thank you for listening.